Okay, so today we're going to be adding fractions with non-unit fractions. But first, we need to talk about the part-whole definition. So, the part-whole definition is seen as A over B, which indicates that a whole number has been split into B-sized pieces. B is the denominator. A, which is our numerator, is the part of the fraction that is being considered. So now let's move on into our problem. So the problem that I'm going to be using today is Matt ate 2/3 of the pumpkin pie. Tegan ate 1/4 of the pumpkin pie. How much of the pie did Matt and Tegan eat all together? So we have 2/3 plus 1/4. And I'm going to show you how to do this with the linear model. So first we're going to set our whole, or our length, which is a whole, which this represents, there you go, the pie that is in question. So Matt ate 2/3, so we need 1/3 and 1/3. So that gives us 2/3, and Tegan ate 1/4. So we'll line this up next to our whole pumpkin pie. And so we're going to find out how much of the pie they ate all together by adding. But first we need to find a common unit fraction. So we can, and they do not have a common unit fraction. So we have to find the common unit fraction. So we're going to fix this and go through the options of finding it. And we're going to see if 1/6 could be our common unit fraction. So let's see. 1/6 fits, like the pieces fit evenly into 1/3. So that would be good. So now let's try our 1/4. So 1/6 does not fit evenly into 1/4, as you can see on the camera, because this piece of the 1/6 hangs over. So we know that doesn't work. So let's try another unit of fractions. We're going to try our 1/12ths. So we'll see if they fit evenly into 1/3 first. And all these pieces fit, like the pieces that line up against with the 1/3 fit evenly. So now let's make sure that our pieces fit evenly into 1/4. And they do. So we found our common unit fraction. So now we can move on to the adding part of this problem. So we're going to fill our second third with our pieces of 12. There we go. And so now we can find out how much of the pie they ate all together by adding our 1/12ths up, since they are lined up right alongside our problem. So let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11/12ths of the pie was eaten by Matt and Tegan. Now let's move on to our area model. So we have our whole piece of the pie once again. This is the whole pie. So we know that Matt ate 2/3. So there's 1/3 and there's 1/3. That is all what Matt ate. Let me picture this better so you can see it. Okay, and Tegan ate a fourth of the pie. This shows how much of the pie they ate. So now we're going to find out once again how much of the pie they ate together by using this area model. But we also need to find out once again a common unit fraction. And we know that a sixth does not work. It does not evenly, the pieces of the sixth do not evenly fill a third or a fourth. So that doesn't work as our common unit fraction. So let's try another one, see if there's any other options out there. Let's try an eighth this time. Here's our eighth, and we're going to try a fourth, see if it fits. Okay, so our two 1/8 pieces fit evenly into the fourth. So let's see if it works for the third. These three 1/8 pieces do not fit evenly into our third piece because when we compare them to like lay them on the surface, it hangs over. The last eighth piece that could fill it hangs over. So we know that an eighth is not our common unit fraction. So let's try a 1/12 again. So here's our 12 pieces. So let's try a fourth. So it once again fits evenly into the fourth. So we'll try the third. So 4 pieces of 1/12 fits evenly into a third, and 3 pieces of 1/12 fit evenly into our fourth. And so we now have found, again, our common unit fraction. So let's go ahead and fill our remaining third that Matt ate in with 1/12, our common unit fraction. So now we can easily count and see how much of the pie Matt and Tegan ate together. So let's go through and count how many pieces of 1/12 we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They once again ate 11/12 of the pie.